circle for a longer time. Also, minimizing raw material use. It creates a cradle-to-cradle kind of scenario, and also it shifts focus from being resource intensive to being labor intensive, creating more jobs. So just to make some things clear, and this is the recycling process. So I just want to make these things clear so that you understand what I'm speaking about when I say repurpose. So in comes the circular economy. The circular economy is constructed in a way to keep materials in a loop, with minimizing new renewable or finite materials into the circle. And you want to be close as the user. You want to be keeping this loop as small as possible and make it as efficient as possible. And the further out you get here, the less, the worse it gets, so to speak. So, what we did was the following: literature review, field study, empirical data, and conclusions. And this was the objective: evaluate the possibility to implement the reuse strategy. And this is for the building sector. And to do so, the following things I'm going to present to you are in this area. We'll touch some conclusions in the end, but the main focus is here. All right, so first of all, we have some soft parameters. We wanted to make some interviews with the building sector and big actors in the Swedish building sector to figure out if there's any problematic aspects of reusing building materials. And what we found out was this: planning, early stages, and deadlines. Those are, let's say, their main concerns. And this was repeatedly coming up when we were doing the interviews as well. Logistics, availability, quality, and warranties. This was also a very important aspect to the persons we interviewed. Especially quality and warranties. Because when you buy new products, you get warranty and you get a quality control. When you buy a reused product, you might not get the same warranty or quality that you're looking for. And also they were sort of asking for a key actor to handle all of these aspects. As a builder or a contractor, you don't really want to be into the logistics and be into the availability or quantity of the products that you're selling. So they want somebody else to handle this. And right now, components aren't designed to be reused. They're designed to be used once and then discarded. So in order for this to work, they indicated that we need to start building so we can dismantle. As one of the interviewed persons said, and this concludes everything very well: we are not able to handle the logistics. Somebody else must take responsibility over handling, renovation, and refurbishments. Solutions that are present today are in too small quantities and too late in the building process. So, with this, we wanted to investigate further. We wanted to look at the components and see, okay, is it really feasible to do this in the technical level? So we chose bricks and windows to investigate further. And today I will be showing you the calculations we did on windows. And we chose windows because they both have aesthetical and an energy performance factor. And that is important for the calculations that I'm going to show you next. Technical data and labor intensive are two factors that are also very pressing. Labor is very expensive in Sweden, and that unfortunately makes it difficult to get profit from reusing materials. And also a lot of technical data is lost due to old materials. When you buy a new window, you always have your specifications. So you know what you're building, you know what your energy performance will be. Reused materials are often not attached with technical data. And as well, quantities. Right now the quantities of reusable materials are very low in Sweden. Around, I think, 10% of all waste is reusable. So it's also problematic for big actors to, when they're constructing in a large scale, to be able to get the parts they need. I don't recognize these figures, but this is supposed to be houses. We had fitted houses that we chose to be able to do calculations and compare. So I'll just run them through it real quick. We picked this house not to meet the requirements regarding the building regulations. And this one was a 25% reduction of the energy performance. This house we constructed with the best components available in the market. And the fourth house was with improved windows. That's it. So we ran an LCA, life cycle analysis, on windows, just to see how much carbon dioxide impact do we have just to manufacture a new window. So in this LCA, we used category A1, that is raw material supply, transport to the factory, the actual emissions due to manufacturing, and then we got a total of 101 kilogram CO2 equivalent for 18 windows. And now I will show you the comparison of the usage phase, let's say. So we took two windows. One is reused, this one, and one is new. So if we have a window with the energy performance of 1.1 watts per square meter Kelvin, and one that is worse, 2, we wanted to see how long does it take for the old window to have the same impact as the new window. So we ran this for 25 years, and you can see now the energy inputs for heating in these two houses are a parametric study. So we wanted to see how bad of an energy source do we need for this to be unprofitable or unfeasible. So the figures we got were these, and we're comparing these figures to the embodied CO2 emissions. So the lower ones are better, and this energy source overshot by almost 1,000. So this shows that depending on what energy source you use, this could be feasible or not feasible. And we did this because we wanted to attach the economy to these figures. I will show you this real quick because it's Swedish figures and I might not be very relevant, but I would just like to illustrate that there is some financial gain. So if you would erase one figure here, this would be in euros, and if you would half this, it would be in local currency. this is the price for new windows, the investment cost, and this is 0 due to reuse. The yearly cost, this is the price you pay for heating. The difference would be this, due to the new window having a better energy performance than the old one. So we did a parametric study to see how many years and how many figures we could get. And a comparison shows this. So for 15 years, you would have 123,000 Swedish crowns extra in your pocket. This is due to the investment cost being 0. And looking at the parametric figures, we can see that it doesn't change that much depending on the different values. And this was also ran with the growth rate of 2% and an inflation rate of 2%. That is typical figures for Sweden. So we made some conclusions. I'll run them through real quick. There is no adaptation for further cycles in the building sector. So the components are made to just be used once. There could be a push in moving towards a more circular model, but this needs to be handled by the government. Because the products that are sold are getting double taxation. You pay tax when you buy it new, and then you have to pay tax again when you want to sell it as a reused model. So this is something that needs to be assessed. Low volumes is a problem, especially for builders that are building big and complex buildings. They want the same standard everywhere, same doors, same windows. They don't really want to do the hassle of reusing components. And our calculations indicate that if you look at the pure environmental gain, the changing of windows is unfeasible. Now, I want to be clear that there could be more, let's say, comfort reasons for changing windows. So if it's not pure environmental, then of course, changing windows would be a good idea. But this is what our calculations indicate anyways. Contractors and architects, these are, let's say, the actors in the early stages, and we think that these actors are carrying the burden of pushing this reuse mentality through. Because if it doesn't come in the earliest stage, it's not feasible at the end. And of course, the desire for a key actor, it's reasonable to have one actor handling all the warranties, all the logistics, all the transport, as of if you would have a new parts manufacturer. So we need someone to be equivalent in the reuse side. And actually, one thing that we found out to be very positive and also very shocking, price of reused components doesn't appear to be a deciding factor for the contractors. We performed a lot of interviews and we talked to a lot of people. Not once did they complain or say anything about the cost of the actual component, indicating that they would be happy to pay a higher price for a reused component.